All about isotopes. Welcome to podcast 1.3b. How to build an atomic model in 3 easy steps. Step 1, look at the protons. So for example, if we're looking at boron, atomic number 5 tells us we have 5 protons, so these 5 red spheres. And then, according to this, you have to have the same number of electrons. So make sure that there are 2 electrons, these blue spheres, on the first energy level, followed by 3 on the outer energy level. Finally, the neutrons. You can estimate neutrons by making sure that they, together with the protons, that is the red and gray, add up to the mass average, which is up here. 10.81 is close to 11, so we have already 5 protons. So simply add 6 of these gray neutrons, and you have the correct number in the nucleus, and there you have it, the model for boron. Drawing an atomic model of nitrogen. So nitrogen has an atomic number of 7, so you have 7 protons in the center. Then, since atomic mass average for nitrogen is roughly 14, you would put another 7, only this would be neutrons, so we'll use closed circles. So you have 7 neutrons and 7 protons. And then finally, 7 is also the number of electrons you have. So you have a ring, 2 electrons in the first energy level there. And then your outer energy level, you would have 5 electrons. 1, 2, 3, 4, 5. So these are the protons, you have these are the neutrons, and these are the electrons. Okay. Atomic mass of an isotope. So this is what you would see on the periodic table. This is called the atomic number. This is the symbol, this is the name, and this is the mass average. If you want to get an estimate number of neutrons from this information, you would simply take the total mass, subtract the protons from it, and if you round that, that'll be the number of neutrons, or the other particle in the nucleus. Isotopes of an element. Isotopes of an element have this same number of protons, or these red spheres, but a different number of neutrons, or these gray spheres. They all contribute to the mass, and that's why their masses are different, because these 2 isotopes are larger than carbon-12. So that's how isotopes are the same and different. Same atomic number, or protons, but different mass, or neutrons. As you can see, this is the same thing. Notice how there are 2 ways to write the symbol, this way, where you have mass number over atomic number, or this way, where you just show the mass. To find the average mass, you simply take the total mass. To get the total mass, you take each atom, multiply it by its mass value. So here in the blue we have 90 atoms multiplied by the mass. In the yellow, for neon 22, we have 9 of those particles, so multiply it by its mass. And then only 1 neon 21 particle, so 1 times 21. Now you just divide it by however many atoms you have, and you calculate the average. Just as a check, notice that your average is somewhere in between all of the masses, and averages always are. Example problem 1, and so now we have 3 example problems. Problem 1, we can just go ahead and put in The symbol for fluorine is F. Atomic number is 9. So if you look on the periodic table, you also get from the atomic number the number of protons and electrons, and from the from the periodic table again, averaging the mass, you have roughly 19. Now to get the protons, or to get the neutrons, you subtract the protons from the mass, and so that'll give you 10. Now the clue here in the next row is that the protons is 8. So that right away identifies the element as atomic number 8, or oxygen. So we know this is oxygen. We can now go back, know that the electrons have to always equal the protons for an atom, and then adding protons, looking at the mass average on the table, it's 16, so that tells us that our mass for the neutrons is 8, since protons and neutrons must add up to the mass. Going on to example problem 2, if you find the element iron on the periodic table, you will find that its mass average is roughly 55.8. So 55.8. The atomic number happens to be 26. It asks you which isotope would be present in the greatest abundance. So it turns out that iron, you could write it as iron dash 56 or 56 Fe 26. Either way, you would be showing the isotope with a mass of 26, and it would be present in the greatest abundance because the average is closest to that mass number. For the last example, this is another variation on calculating average atomic mass. Okay, we first can do a prediction. What do you think is going to be the average? Is it going to be closer to 35 or 37? Since there's more of 35, you can go ahead and guess that your average is going to be closer to 35. To calculate this, you take the percentage of 35, multiply it by it. Then you add it to the percentage. Oops. So that's a 24.2423 of or times 37. Alright, so if you add these two products together, you'll get roughly 35.5, which is the average, and it makes sense because, as we predicted, the average will be closer to 35 than 37. And this concludes today's podcast. Thank you for watching.